For this lesson, we're going to be talking about converting into slope-intercept form. So you might see a problem like this, 3x plus 4y equals 12. And you're going to be asked to convert it into slope-intercept form. The thing we got to remember is what slope-intercept form is. So to convert to y equals mx plus b, we need the y to be by itself. We need to isolate the y. Okay, that is our goal here. There's a two-step process that you can do pretty much every time you do these problems. And I'm going to show you guys right here. 3x plus 4y equals 12. All we do is two steps. We first move the x using our inverse operations. So how it would look is I need to move this whole term right here. I want to move that to the other side. How do I move a positive 3x? Well, opposite of positive is negative. So I'm going to minus 3x from both sides. Okay, my x's cancel on the left. Now I have to recognize I cannot combine the 12 and the 3x because the 12 is not an x term. The 3 has an x after it. These two are unlike terms. So I have to keep them separate. I'm going to bring down my positive 4y. I have it equals. I like to put my x term in the front and my number term in the back. Why do I like to do that? Because remember, we're trying to get this into y equals mx plus b. With the slope-intercept form, the x comes first, so I like to do that in my solving. After we move the x, our second step is divide by whatever is in front of the y. So we're going to divide each term by the value in front of y. So in this particular case, y has a 4 in front of it. I'm going to divide every single thing by 4. 4's cancel. I now have y by itself. I'm going to keep this guy as a fraction. So negative 3 over 4. I'm also going to keep the negative in the numerator. Why is that? Because if I have to graph it, I like to have my negative on the numerator. It's just easier for me. And then 12 over 4 is, of course, 3, positive 3. Boom. There we go. And if you have to graph it, again, you can just pull out the slope and the y-intercept, and you are ready to go. Let me show you guys two more examples real quick. Now, I'll see if I can fit them down here. So, two examples. I've got 2y minus, or 2x. Oh, I'm going to erase that. Fresh start. Whoop, here we go. 2x minus y equals 6. Well, two-step process. We're going to move the x, minus 2x both sides. I now have a minus y. Swing my variable to the front, my number to the back. That's my first step. My second step, I have to divide each term by whatever's in front of the y. I'm going to put an invisible 1 right there. I divide everything by negative 1. Whenever you divide by negative 1, you pretty much just change the sign. So my negatives cancel, and this guy becomes a negative 6 over there. Oh my. So I have y equals 2x minus 6. Boom. Okay. That's bugging me. I'm going to fix that. Divide by negative 1. Yep. And that's it. Let me give you one more, just for fun. We got the space, might as well use it. Minus 12x minus 3y equals 36. So this time we have a negative 12 out front. We'll write it a little more nicely. Negative 12 x minus 3y equals 36. We do the same process though, guys. All we're going to do is we are going to do the opposite of negative 12x, which is positive, or plus 12x both sides, plus 12x. And now we just have a negative 3y equals, bring the x term to the front, and the number to the back. From here, our second step is to divide each term by the value in front of the y. So we're going to divide everything by negative 3. We have to be aware of our negatives and whatnot here. I have y by itself. 12 over negative 3 would be negative 4x. And 36 over negative 3 would be negative 12 or minus 12. And bop, there we have it. So, again, hope that was helpful. Thanks for watching and have a good day.